Hi there, welcome once again. My name is Nathaniel Mensah, and of course, I'm your maths tutor. Today, we are looking at one very important subject, sets. This one can be found in both general mathematics and further mathematics. But before we go on to what we are going to do, don't forget to subscribe. If this is your first time of watching us, just click that subscription button so that the next time, also don't forget to click the notification button so that the next time we post a video, you will be the first person to have a feel on it. Also comment, we will need your comment as well, anything you want us to do or addition or any subtraction, or if you have any question, you can also comment at the comment section as well. All right, so today we are looking at sets. Now, when we say set, what are sets? Now, sets are actually basically, we say root of irrational numbers, mostly root of irrational numbers. Remember when we were studying rational and irrational numbers, we said a rational number can be expressed as a fraction, but irrational number cannot be expressed as what? A fraction, as a common fraction, right? So a typical example of a set is root of 3. For instance, if I have something like root of 3, right? Root of 3 cannot be expressed. This cannot be simplified, right? You get a non-terminating answer. But if I have something like root of 4, we know root of 4 is 2. The reason why root of 4 is 2 is because root of 4 is the same as root of 2 squared. And we all know square cancels square root. The final answer will give you 2, right? Now, another typical example is root of 9. Root of 9 is 3. This is because root of 9 is the same as root of 3 squared. And 3 squared cancels the square root. So at the end, we have what? 3. Right? Alright, so all these ones are called the ones that can easily be simplified out of the square root. They are mostly rational numbers. And numbers that cannot be easily simplified from the square root, they are called irrational numbers, right? So a typical example of the irrational numbers, we can have root of 2, we can have root of 3, root of 5, root of 7. You realize that root of 11, you realize that all these ones cannot be simplified out of what? The square root, okay? And then examples. Example like irrational numbers, which are the perfect squares. We have root of 1, which is 1. We have root of 4, which is 2. We have root of 9, which is 3. We have root of 16, which is 4. We have root of 25, which is 5. We have root of 36, which is 6. Sorry. We have root of 49, which is 7. We have root of 64, which is 8. We have root of 81, which is 9. We have root of 100, which is 10. So it goes on like that. So root of 121 is 11. Now root of 144 is 12. Root of 169 is 13. Root of 144 is 14. Is that also? Okay. So it goes on like that. So you realize that all the ones that are rational, are the perfect squares we know, right? We know, right? They are the perfect square, right? So whenever you see the sign this, right? The sign this means what? Positive square root. Positive square root, okay? So in simple terms, we can say a set is a square root of a prime number. You realize all these ones are prime numbers. So whenever you have a square root of a prime number, then we say it's what? A set. Are you getting it? So all these ones are what? Sets. Okay. All right. So let's look at how we can reduce set. Now, when you are given a particular set and you are told to reduce it, it's very simple. You split the numbers into two such that one becomes a perfect square and one becomes an imperfect square, or one becomes what we call a rational set and one becomes an irrational set, right? Now, a typical example, if I give you something like root of 3, you cannot express this in any form. You cannot reduce it. But if I give you something like root of 12, you see root of 12 is the same as root of 3 times 4 is going to give me 12. Look at what I did. I split this one into two such that one became a set, an irrational number, and one became what? A rational number. That is what we do. When you are reducing a set, that is basically what you do. You split it into two such that one becomes a rational, one becomes an irrational set, right? Of course, so in layman's language, when you split a set and you want to reduce it, make sure one becomes one of these ones. Okay? Either it becomes 4, 9, so that it can easily come out of the square root. If the other doesn't come out of square root, it is not a problem at all. Okay? So this one is the same as, remember this one is the same as root of 3 times root of 4. And we all know root of 4 is what? 2. Right? Root of 4 will give me 2. Right? So the final answer is 2 root 3. 2 times root 3 is the same as 2 root 3. Okay? Now let's take a typical example again. This time let's take an example like root of 50. Now if I have root of 50 is the same as root of 2 times 25. Okay? Root of 2 times 25. And we know this one now. Root of 25 will give me 5, right? So this one becomes 5 root 2. Because it's the same as root of 2 times root of 25, right? This is root of 2 times 25 is 5. So 5 times 2 is going to give me 5 root 2. Do you get that? Now, when we take a typical, let's take another example. Root of 300. So if I take an example like root of 300, this is the same as root of 3 times what? 100. And we know root of 100 is what? 10. So this one is the same as 10 root 3. Okay? Let's take another example, root of 24. If I take root of 24, this one is the same as root of 4 times 5. But we all know root of 4 is 2. So this one is going to be 2 root 5. Right? We always leave the irrational number in the square root because that cannot be simplified. But 2 can easily come out of the square root. 4 can easily come out of the square root to be 2. You can see here, right? So this one means 2 squared will give you what? 4. When you square this one, you get what? The 1 inside the square root, right? Let's look at one last example, then we'll go to addition and subtraction of set. We have another example, root of 27. So how do I split this one so that one becomes rational, one becomes an irrational, one becomes one of these, and one becomes also what? One of these, right? You realize that if I multiply 9 by 3, I'm going to get what? 27. And 9 comes out to be 3, so the final answer is 3 root 3. Are you okay? Alright, now let's go to addition and subtraction of sets. Addition and subtraction of sets. Right? So let me clean this particular aspect. Okay. Now, in general, if you are given a common set, right, a group of sets to simplify, a typical example, in general, if I have, in general, if I have m root k plus n root k, then this is going to give me m plus n root k. Just as we add algebra, when you have 2a plus 3a, it becomes what? 4a. 5a, sorry. When you have 6a minus 3a, it becomes what? 3a. You just subtract the numbers and leave the particular component. That's the same way you do this. So in the same way, if I have m root k minus n root k, then it becomes m minus n root k. Do you get what I mean? So for instance, if I have 3 root 2 minus 5 root 2, since they have the same root, then I can perform the operation, right? So this one is the same as 3 minus 5. Since they have the same root, forget the root and then perform the operation on the numbers. 3 minus 5 is what? Minus 2. So the final answer for this one is minus 2 root 2. Okay? Now, if I have something like 10 root 3 minus 5 root 3, since they have the same root, this one 10 minus 5, so this one becomes 5 root 3. If I have 3 root 5 plus 4 root 5, since they have the same root, I can perform the operation. So I just add 3 and 4. So this one becomes 3 plus 4 becomes what? 7. So this one becomes 7 root 5. Right? What if I have 4 root 7 plus root 7? What happens? Right? Remember, whenever a variable or number is standing alone, there is always 1, but it's invisible. We don't write it. So this one is the same as 4 plus 1, but we don't write the 1. So this becomes 5 root 7. The same way, if I give you 2 root 3 minus root 3, remember there is 1 here, right? So this one is the same as 2 minus 1. That becomes 1. So 1 root 3. But remember, we don't write the 1. So this is the same as root 3. Are you okay? Now, someone may ask, what if the roots are different? 2 root 5 plus 3 root 4. You cannot do anything to this, right? You cannot add nor subtract because the roots are different. The same way, if I give you 2x plus 4y, you cannot add these two because they are not the same. The same way, you cannot add this. So you leave this as it is, right? Remember, you can, if I give you 5 mangoes plus 3 mangoes, you can tell me it's 8 mangoes. If I give you 2 mangoes plus 3 mangoes, you can tell me it's 5 mangoes. But if I give you 2 mangoes and 7 oranges, how are you going to tell me? Is it mango or oranges? No, it doesn't work that way. Okay? Alright. So this is how we add or subtract a set. Okay? Now, in some certain instances, they will give you a set that you have to simplify before you add or subtract them. Okay? Now, a typical example. Let's look at a typical example here. If so, I have here I have root of 147 minus root of 75, then plus root of 27. Okay. So how do we split root of 149? Root of 149 is 147 is the same as 49 times 3, right? 49 times 3. And then we all know root of 75 is the same as 25 times 3. Okay, remember we are making one rational, one irrational. You realize that all the numbers that I'm making are the perfect squares. So as much as possible, try and make one a perfect square, right? And then plus, this is the same as 3 times 9. Now you realize that almost all the imperfect squares they said are the same. Not almost, they are all the same. 3, 3, 3. Why I set the questions in such a way that you get most of the irrational number being the same so that you can perform the operation. So because remember, if they are not the same, you cannot add or subtract. Are you getting that? And let me show you a simple trick here. Now, supposing you are in an examination hall and 147, you are wondering which two numbers will I multiply to get 147, such that one becomes a perfect square. It's very simple. All what you do is start dividing 147, divide by the irrational numbers. That is the prime numbers, right? And see which one will give you a perfect square. If you divide 147 by 2, it's not going to give you a perfect square. Then you continue. If 2 doesn't give you, then go to the next one, 3, the next prime number, 3. So if you divide 149 by 3, you realize you get 49. And 49 is a perfect square, which means that when you multiply 3 by 49, it's going to give you 147. If you come here, for instance, just multiply this one, divide it by 2, sorry. So you divide, rather, just divide this by 2. Divide them by the irrational numbers. 75 divided by 2 is going to give you what? It's not going to give you a perfect square. Then you go to 3. 3 is going to give you a perfect square. Which means that 3 times, because when you divide 75 by 3, you get 25, which is a perfect square. So it gives you a clue. So 3 times 25 is going to give you what? 75. Are you getting that? So this one is the same as 7 root 3 minus 5 root 3 plus 3 root 3. Right? And since they are all the same, we can perform the operation, right? So 7 minus 5, that's going to give me 2. And then 2 plus 3, that's going to give me 5 root 3. Right? Let's solve 2 more examples on this, and we'll draw the curtain on this particular episode. And the next one we'll do multiplication and division. So allow me to clean this part. Let's take another example. So the next one I have root of 24 minus 3 root 6 and then minus root of 216 plus root of 294. Okay. So now this gives me, you know, this one is the same as 4 times 6. This is minus 6 root 6. We can't split this because there's no number that I'll multiply. There's no number multiplied itself will give me, or another number will give me 6. No number which when multiplied will give you 6, which one will become rational, one will become irrational. It doesn't exist, so I maintain it like that. Then minus root of 216 is the root of 216 is the same as 6 times 36. So 6 times 36. And then root of 294 is the same as 49 times 6. So you realize that this one now becomes what? 2 root 6 minus 3 root 6 minus 6, 36 comes out to be 6 root 6, and then plus this one is 7 root 6. Alright, so this and this, you realize that if this minus this is going to give you minus root 6. And then this and this, because they have the same root, I'm just doing it one after the other. This and this is going to give me plus root 6. So the final answer is going to give me what? 0, because minus 1 plus 1 is what? 0. Right? So let's take one last question, and then we will draw the curtain on this particular episode. This one, let me take a fraction. What if I have something like 3 root 8 plus 3 root 200 plus 2 on 3 root 162, right? So what do I do? So this one is the same as 3. We can split this, right? This is the same as 2 times 4 plus 3 into bracket. This is the same as 10 times 100. Right? Sorry, 2 times 100. And then plus 2 roots 3, 2 over 3 roots. This is the same as 81 times 2. Yeah, 81 times 2. So you realize this becomes 3 now. Remember, 4 comes out to be 2. Because there's a number already out, the 2 multiplies the number out. So this becomes 3 root 2, 3 times 2 root 2, plus when 10 comes out, it meets the 3 to multiply it. So it will be 3 times 10 root 2. You know 100 comes out to be 10. And then plus this one, 81 comes out to be 9. So it's going to be 9 times 2 root 3, then root what? 2. So, you know, this will give me 6 root 2, plus this will give me 30 root 2, plus, you know, this will cancel this 3 times, 3, 2, 6, so 6 root 2. So at the end, since they are all having the same root, I can perform the operation. So 6 plus 30 will give me what? 36, and 36 plus 6 is going to give me what? 72. So the final answer is 72 root 2. Alright. So this is where we draw the curtain on this episode. On the next episode, we are going to look at multiplication and division of sets. Thank you. Until we meet next time. Bye.